So let us draw the relationship between reproducibility, repeatability, and the test variation, because you have no option than to learn this. Okay. Suppose there is always a variation when you reproduce. When you reproduce certain things, okay, when 2 or 3 people try to measure the same thing, there will always be a variation. That's what we call as sigma reproducibility, because the variation is represented by the word sigma. And when you're trying to repeat also, there is a variation, because I'm trying to measure this over and over again. There is a small variation, and there is a variation is represented by sigma, and there is a sigma repeatability. And so the sigma test value is represented like this. And we will put this, we also know, no? What is this theorem called? Yeah, Pythagoras theorem. Now, do not get bothered about this formula, because the software will give you all the readings, okay? But then I thought I must show a little bit of math behind the software calculations. I'll show a little, because you cannot blindly believe the software and you'll not get a feel for learning if software does everything. So there should be some little bit of mathematical background we should know before we understand this. So this P over T, 6 times this standard deviation by tolerance. Let me explain to you. We call that as precision to tolerance ratio. My sincere request is, do not remember this. Just take it and leave it. That's why God has given us 2 years. Okay, take it and leave it, but you must take it. For some, it might get processed inside and become interesting. For those who it's not interesting, I know, because mathematics generally dry, you can take it and leave it, because the computer is going to do everything. But then you should know this knowledge. At some point in time, when you want to explain to your subordinates, if they ask you, what does it mean, significance of this, please tell me. You should be able to explain at least, okay, let me refer to Dr. Murali's slide and show that, okay? The basis is 6 times the standard deviation. If you see the normal distribution curve, when you measure data, there will always be a variation. And there is a formula for calculating the standard deviation, and 6 times standard deviation. It will account for 99 to 100% of the variations. Okay, 99.99. Okay. Now, this is tolerance, means upper specification limit minus lower specification limit. This is simple, right? Tolerance is nothing but I'm tolerating this band. You can learn. It's a range under which your variation should be. So it includes both repeatability and reproducibility. If this ratio is 10% only, that is 6 times the standard deviation of a measurement variation, which is repeatability and reproducibility, is less than 10%. The allowable is 10%, because you cannot avoid the measurement variation. Cannot avoid the measurement, but you can reduce the measurement variation. Measurement variation, we saw, primarily comes because of repeatability error and reproducibility error. Repeatability error is, I am repeating, I'm not getting the same reading. The reproducibility is, both of us are measuring, I'm getting one reading, he is getting one reading. There will always be a variation, but this variation is okay. You cannot avoid this variation, but you can reduce this variation. You should first check whether this variation is less than 10%. So 6 times this variation over the specification limits. If it is less than 10%, it is great. You can go ahead, use this measuring equipment, use these operators, and go ahead and measure the pieces. All right. Now you're good enough to go. Muraliji, what if that variation is a little bit more? I'll ask you a question. Little bit means how much? Sometimes it's 20, 30%. I would say keep a watch. Go ahead and measure, because you have a danger of rejecting a good part or accepting a wrong part. How many of you understood what I said? With measurement error, you have a danger of two types of risk. One is accepting a wrong part and sending it to customer, which is consumer risk, or rejecting a good part and keeping it inside the factory is a producer risk. Because if you accept a bad part and give it, the water is not good, you have accepted it and distributed it, what will happen? Consumer risk. Rejecting a good part, that is, water is good, but then you have rejected it. Whatever I produce is waste. So I've sort of introduced these two terminologies now, but then I would say, don't stop your measurements, go ahead and measure, but try to improve your measurement systems. But if it is greater than 30%, never use that. Okay, there's no point in measurement because it will not represent your true. It is called type 1, type 2 error, alpha risk, beta risk. We'll talk about all that later. Okay. For distractive test, there is a recommendation that up to 50% is okay.